Okay, hello again. This is now part 2 of our discussion on partial fraction decomposition. So now yung focus natin is for denominators with at least one quadratic factor. We have to subdivide this again into two separate cases like with the linear case. Our first case is what if your quadratic factor appears only once in the factorization. Then corresponding to this, we have the partial fraction. So instead of constant over the factor, we now have here linear ax plus b divided by the factor. Tapos, if your factor is repeated here n times, halimbawa, where your n is greater than 1, then the partial fraction corresponding to that is somewhat similar to that in the linear case, no? Except this time, yung mga numerators nyo puro linear sila. Other words, we have here a sub 1x plus b sub 1 all over the first power of your factor, plus and so on. So again, you increase the powers of the denominator, no? Then you will stop nth power here. You have here again linear over the nth power of your factor. So let's illustrate all of this with examples. For example, number 3, let's integrate this. So as usual, to decompose the integrand into partial fractions, you have to factor out the denominator, no? So when you factor out the common factor of x squared, what will happen? We'll get now x squared, then times x squared plus 4 in your denominator. If you notice, itong x squared na to, this is in fact x times x, no? So it's the linear factor x, and it appears twice in your factorization. You expect two partial fractions corresponding to. Meanwhile, this one, x squared plus 4, that's a distinct quadratic factor, no? So there's one partial fraction corresponding to that. Have here two partial fractions plus 1 here, you expect a total of three partial fractions. So when you now decompose into partial fractions, yung x squared corresponds to a over x squared. Tapos yung x squared plus 4, remember yung numerator natin is linear, c plus d, divided by the factor x squared plus. Then as usual, we determine the constants a, b, c, and d, no? Our go-to technique for that is clearing out denominators in the. So in particular, let's multiply both sides of this equation by x to the fourth plus 4x squared. If you multiply that one on the left, what will happen when you multiply this by x to the fourth plus 4x squared? This will cancel out, no? That leaves you with only the numerator. Then on the right, what will happen if you multiply all of this by x squared times x squared plus 4? Let's go over this one by one. Have here a over x multiplied by x squared times x squared plus 4. Yung x squared divided by x, that's just x times a, and then times x squared plus 4. That's your first term ngayon. Yung b over x squared, the x squared will cancel out. Tapos you're left with b and then times x squared plus 4. Tapos dito naman, the x squared plus 4 will cancel out, leaving you with cx plus d and then times x. Then instead of what we've done earlier where we take particular values of x, yung gagawin natin is we'll compare coefficients. To do that, we have to expand the terms on the right-hand side and then combine like terms. So distributing ax to this binomial, we should get here ax cubed and then plus 4ax. Ito naman, you should get bx squared and then plus 4b. Then finally, for this term, you should get cx cubed and then plus dx squared. And then the next step is to combine like terms. For instance, combining the terms with x squared in them, what are they? You have here an a and then plus c. A plus c yung coefficient of x cubed. Next, for x squared naman, for x squared, you have here b and then d. Tapos for x, our sole x term is 4ax. Our only constant term is 4b. Okay, so this polynomial is now equal to this one for any possible value of. They're identically the same. Yung gagawin natin is we will now compare coefficients, this equation that we got. So for instance, if you now compare the coefficients of x cubed, on the left, wala kayong makikitang x cubed dyan, no? So automatic 0 ang coefficient on the left. Then on the right, you have here an a plus. Call this equation 1. Next, for x squared, on the left, you have 2, and on the right, you have b plus d. Call that equation. For x, you have negative 8 on the left and 4a on the right. So dito ngayon. Tapos for the constant terms, you have 12 on the left and 4b on the right. Let's call that ngayon equation number 4. Now, if you notice, in equations 3 and 4, you can get the values of a and b already, no? Bawa in equation 3, you can divide both sides by 4. We will get a equal to negative 8 over 4, which is negative. Okay na yung value ni a na yan. Using this value of a, we can look for the value of c in equation 1. Equation 1, what's the value of c? If you transpose a to the left, it will become negative a, no? So we're left with the equation c equals negative a. But your a is negative 2. Your c is now the negative of negative, now equal to positive. So okay na yung c na. Next, if we now focus on equation 4, let's again divide by 4 para ma-isolate yung. Do that, you will get b equals 12 over 4, which is now 3. Is 3. Similar to this one, let's use now equation 2 to determine the value of b. The value of b is what now? Transposing b to the left, you're left with the equation b equals 2 minus b. But then your b is 3. You get here 2 minus 3, which is negative 1. Those are your values for the constant. Have here a equals negative equals 3 equals 2 and b equals negative 1. So let's now integrate. So the integral of this one is equal to the integral of the partial fraction form. Then replacing the constants, you have here a equals negative equals 3 equals 2 and your d is negative 1. And then let's integrate all of this term by term. Dalawang to, let's integrate them term by term. And then for this third term here, let's split that as a sum of two fractions. Let's write this as 2x over x squared plus 4 minus 1 over x squared plus 4. Have this one. And then we integrate term by term. So for this one, this is more or less easily integrated, no? We have a negative 2 sa labas. And then the integral of 1 over x, remember, it's ln of absolute value of x, no? Have negative 2 times the ln of absolute value of x. Meanwhile, for this, remember we discussed this earlier, the antiderivative of 1 over x squared is negative 1 over x. Multiply that by 3, you get negative 3 over x. Okay na itong dalawa. So, ang emphasis lang talaga natin is itong integral na to and this one. Let's start first with this integral here. For 2x over x squared plus 4, ano yung pwede natin gawin? Pwede natin gawin is we can let u equal to the entire denominator. We'll see in a bit kung bakit yun yung pwede natin gawing substitution. If your u is x squared plus 4, then what is your du? Ano yung derivative ng x squared plus 4? This is 2x, this is 0, so 2x lang yan. And then multiply by dx, you get, of course, 2x dx. And if you notice on the integrand itself, we have here a 2x multiplied by dx, so viable substitute. Okay, so let's now express this in terms of u instead. In terms of u, ang 2x dx, that's equal to d. Your numerator is now du. Divided by x squared plus 4 is equal to, we assigned that. Tapos ano yung antiderivative ng 1 over u? Precisely the ln, of absolute value of u plus some constant. And then back substituting the values of x here, you have the ln of absolute value of x squared plus 4 plus k1. So if you want, you can remove the absolute value bars here and replace them with parentheses. Positive naman si x squared plus 4 for any x. Pero this form will suffice. This one now equal to the ln of absolute value of x squared. Let's turn to this one ngayon. So if you recall from Math 21, this is in fact an integral of special form. This will yield an inverse trigonometric function. Recall, the integral of 1 over x squared plus a squared, what's that equal to? It's precisely 1 over a times tangent inverse of x over. So in this particular case, ano yung value natin kay a? It's the square root of 4, which is 2. So itong integral na to, using this formula here, it should be equal to 1/2 then times tangent inverse of x over plus some constant. So this will become 1/2 arctangent of x over. And then you're done, no? So your antiderivative is now equal to this entire thing plus an arbitrary constant. And that's it. Okay, next example number 4. Let's find the integral of this function. Again, compose the integrand into partial fractions, what will happen? Now, si x squared plus 2x plus 2 is in fact an irreducible quadratic polynomial, no? Kasi this polynomial, it has no real. Verify that using quadratic formula. So in this case, you have here a quadratic factor, an irreducible quadratic factor, which is appearing twice in your denominator. So when you decompose into partial fractions, what will happen? Now have here linear over the first power of the factor, you have this one. And then plus again linear divided by the second power. And then you stop there. Twice lang yung repetition natin, no? And then as usual, we can clear out the denominators to determine the values of a, b, c. So multiplying on the left by x squared plus 2x plus 2 quantity squared, as usual, mawawala tong denominator na to, no? That leaves you with this numerator over here. Tapos on the right, if you multiply this entire thing by the square of x squared plus 2x plus 2, what will happen? So eto, magka-cancel out siya with x squared plus 2x plus 2 sa baba, no? That leaves you with ax plus b multiplied by just x squared plus 2x plus 2. Ito lang yung first term ninyo. And then plus for this one, magka-cancel out entirely on denominator, no? Pati yung numerator nyo dito mawawala. So all that's left here in the second term is c. And then like what we've done in example number 3, let's expand and then compare coefficients. Of course, combine like term. So expanding this one, what will happen? Let's start with the first term first. We have here ax times x squared, that's ax cubed. Plus ax times 2x is 2ax squared. Ax times 2 ax. Tapos kay b naman tayo. Times x squared is bx squared. Times 2x is x. And then b times 2. Ito yung expanded form ng first term natin. And then we leave cx plus d as it is. Okay, let's now combine like terms. Starting with x cubed, as you can see, there are no other x cubed terms here apart from ax cubed, no? Nag-iisa siya. Next, for x squared, let's see which have x squared in them. What are those terms? They're precisely a, and then plus b are your terms with x squared. Next, for the coefficients of x, sila. They are 2a plus 2b and then plus c. Yung coefficient ni x natin dito. And then finally, for the constant term, you have here 2b and then plus. Okay, so this polynomial now is now equal to this polynomial for any possible value of x. So we can compare coefficients. So starting with the coefficient of x cubed, on the left you have 1, on the right you have a, so call that equation 1. For x squared on the left we have 3, on the right we have 2a plus b, let's call that equation 2. For x we have 4 on the left and then this entire thing on the right. And then finally the constant terms are 1 on the left and then 2b plus b right. Now notice in equation 1 we already got the value of a from the get-go, no? Your a is precisely equal to 1. So we can just use this value of a to solve for the other values. Starting with equation number 2. What do we do to get the value of b in equation number 2? Just have to isolate it, no? So transposing 2a to the left, your b, that will now be equal to 3 minus 2. But then your a is 1. So this is now 2 times 1, that's 2. So this is 3 minus 2, which is now 1. Next, let's look at equation 3 this time. So we now are getting the value of c. We are given now the values of a and b, both of which are 1. So to get the value of z, just transpose these two terms to the left. Your c is now 4 minus 2a minus 2. But then your a and b are both equal to 1. So this will become 2, this will become 2. So this one simplifies to 4 minus 2 minus 2, which is just 0. Negative 2 minus 2, that's negative 4. 4 minus 4 is 0. So your c is 0. Finally, in equation number 4, you want the value of d here, you just transpose 2b to the left. Your d now equal to 1 minus 2b, and your b is 1. Get 1 minus 2, which is just negative 1. So here are your values now. Your a is 1, your b is 1 as well, your c is 0, and then your d is negative 1. So the integral of this one, it's now equal to the integral of the partial fraction form, no? And then substituting the constants that we solved for, your a and b are both 1. So itong ax plus b na to magiging x plus 1 na lang siya, no? And then c is 0, so mawawala sa cx. And then d is negative 1, so this is just negative 1 all in all. Then we just integrate term. Start with this one here. So for x plus 1 all over x squared plus 2x, pwede natin gawin. Let's let u be the entire denominator again, like with our previous example. Let u be x squared plus 2. That's your u, what's your du? Determine the derivative of the right. Yung x squared, its derivative is 2x, no? And then plus, derivative ni 2x is, mag-zero out to. You're left with 2x, and then times the differential dx. Now here's what we can do. Yung 2 is a common factor of both of these, so let's factor that out. And then let's divide d equals 2 times x plus 1 dx by 2. At x plus 1 dx, that's now equal to du over. And if you notice, yung numerator natin is precisely x plus 1 dx, no? Ito yung magandang substitute. Pressing this now in terms of u, yung x plus 1 times dx natin dito, remember, that's now du over 2. And then your denominator is of course just, labas natin si 1 half, tapos si du over u, remember that's the ln of absolute value of u, no? Then re-expressing this in terms of x, now have this. So this one, the antiderivative is 1 half times the ln of absolute value of x squared plus 2x plus. Next, let's do this one. So I won't do this in full kasi you will have to perform a trigonometric substitution. I'll just leave to you yung pinaka-computations, expressing in theta, doing right triangles, etc. Pero let's lay out the trigonometric substitution. So if you notice the denominator, it's not yet in the form that we want, no? So we have to complete the square here. After completing the square, get this. So in this case, our u is x plus 1 and our a is 1. Because of the form function squared, constant squared. So our trig sub will involve tangent, right? For trigonometric substitution, we will let x plus 1 equal to a, which is 1, times tangent theta. Tangent theta lang to. And then getting the necessary derivatives, the left, the derivative is 1 times dx, you get dx of course. Tapos tangent theta, its derivative is secant squared theta times d theta, you get of course this. Your dx is this one, and I'll just leave you to verify that this expression here sa baba, this will turn out to be equal to secant to the fourth of 2. Replace your tangent theta and then perform trigonometric identity, get secant to the fourth. So again, like I mentioned, I won't show this in full, no? You can verify that the antiderivative that you will get here after performing this trigonometric substitution, it should be equal to all of it. Again, I'll leave you to verify that, pero I will give you a hint. So within your expression in theta and anti-differentiation, you will get at some point sine of 2. And yung sine 2 theta na yon, it's hard to re-express in terms of x as it is, no? So I want you to use this identity. Sine 2 theta, it's equal to sine theta cosine theta. So all you have to do now here is to express sine theta in terms of x and cosine theta in terms of y. Kasi ito as it is, medyo mahirap siyang gawin kapag nag-right triangles. Use this identity. Okay, I will conclude this part with this set of exercises. Before that, sige, let's lay out the antiderivative. I have here this one for your antiderivative for the second term. And finally, yung makukuha yung antiderivative is this entire thing plus the arbitrary constant. So going back, I will conclude this with this set of exercises. We will see you in part 3. And this time, yung focus natin in part 3 is what if yung degree ng numerator nyo is higher than the degree of the denominator. Dx dapat to. Okay, I'll see you in part 3.